Businesses need API protection that goes beyond signature matching and can stay ahead of attackers and their various tactics and tools. They need a solution that is more patient and prepared than a modern attacker and can track their actions over time. ThreatX is the only API attack protection platform that delivers on the promise of stopping API attacks in real time while giving you the visibility you need to prepare for future attacks. To learn more, visit securityweekly.com/ThreatX. Your organization is building and updating business-critical web applications faster than ever. And with so much pressure to move fast, you may find yourself making trade-offs between innovation and security. Now you can build fast without sacrificing security with Invicti, the application security platform that helps your dev, sec, and ops teams work together to secure every website, web app, and API. With unparalleled accuracy, coverage, and automation, Invicti scales like no other AppSec solution. Discover why many of the world's largest organizations innovate securely with Invicti. Visit securityweekly.com/Invicti. Welcome back to Application Security Weekly. We just talked with Jason Rekla about the importance of collecting all the logs and how ML can improve the quality of signals that SOCs need to respond to. I'm your host, Mike Shima. I'm here with John Kinsella, and it's just about time for the news. But first, don't forget to check out our library of on-demand webcasts and technical trainings at securityweekly.com/on-demand. And do you have a specific guest or a topic that you want us to cover on one of the shows? Submit your suggestions at securityweekly.com/guests. We review suggestions monthly, and we'll reach out to you once reviewed. And I'm going to reach out to you, Mr. Kinsella, to talk about the news this week, which we've got quite a few articles that are all over the place, although I think I have a theme that I might be able to tease out. Let's see if we can do that. I'm going to start off with a Fortinet flaw, which is normally I kind of skip over these, but the Fortinet and all of these are familiar to those of you listening to the CISA's like top 10 exploited CVEs and top 10 or top 20 exploited devices. But what was interesting about this one is that the exploit is so simple. It's in a forwarded header, and it is just really easy to understand. And it's one of those aspects that's like, wait, how did this happen? Because the write-up is basically just showing how to inject into a header some semicolon delimited fields that get turned into things like a local SSH key that then allows you to SSH into the device, which just seems like for someone like me who's seen a lot of just injection and putting a lot of basically cross-site scripting or spoofing IP addresses within these X-forwarded 4 types of headers, that's getting an SSH key in there to gain access is pretty awesome, I have to say.
Round of applause. Well done.
Yes, thank you. So really, I don't know what the Kinsella scale for that is, but there's definitely a round of applause as we've seen a celebration for that one. So yeah, I just had to throw it in for it. It was fun.
Oh man, so I heard of this last week, but I hadn't. I sort of like I saw first a comment, then like Fortinet was telling like they have this severe, strong urge to their customers to apply this update. And I was just seeing the headlines. I'm like, okay, another Fortinet thing. And it wasn't until I actually looked at this write-up you have until I'm like, oh, I get it now. Yeah. What can you say? I think that it's an interesting write-up from the point of view that, there's a little bit of persistence when they're just sort of like trying to figure out what's going on here. They got into it. They mounted a boot system, a boot image, started digging around and poking around, and like there was some compressed files which weren't uncompressing, and they kept poking and changing and looking at things, and they started realizing, hey, we found a function that what was it called, doing access checks, and then they found a version of access checks for I think specific IPs, if I remember right. You're like, what? Old habits die hard. I guess that would be the can we put that as a vulnerability level? Old habits die hard.
Oh, that's like that covers just about everything, because if we look at the Linux kernel article that I brought up, there were some flaws found in the WLAN or the Wi-Fi stack, which are just your classic memory flaws. So once again, old habits die hard. I think that I highlighted that because I thought it would be just a nice, reference to, hey, we did just talk about Rust slowly creeping into the Linux kernel, and here is just These flaws were identified, I think, about a year ago, beginning of this year. But it's just yet another example that memory safety is going to haunt the Linux kernel. It's a little bit gnarly because someone could light up, like the beacons of Gondor, perhaps, could light up some Wi-Fi packets, beacon packets that the Linux kernel stack will see and then be potentially exploited. So it definitely has a little bit of worries for those of you out there who are running Linux on the desktop. No more comments or jokes on that. I think that's beaten to death. But let's see before I try to keep John from jumping on that angle, I will say this to me was another example of just the idea of bug density, that if you start to look in an area of code, you might find one flaw and then another flaw and then another flaw. And so I'll broaden this a little bit to the idea of a bug bounty report. You get a bug bounty report. They say, here's a dead simple, old habits die hard, cross-site scripting or something like that. Rather than just fix that flaw, look in your own code. Do you see those similar patterns elsewhere? Do you see this misused function elsewhere? And just possibly close off not the single flaw that was found or reported, but all of the other ones that are lurking behind it. So that's the best way I can avoid talking about cliches about the Wi-Fi stack here. Anything you would add, John?
So anyways, back on Linux on a desktop. No, I'm kidding. I like where you went with that towards the end, because I didn't get a chance to pull the actual PR on these. And again, for folks listening, I think this is really interesting, right? Like the last article we just covered where we can sort of see what's going on closer to what's under the hoods. And then here you've got pure source code. So I mean, it's pretty simple to go in and put a tiny bit more effort than I've done so far, but not just looking at the email and the kernel list, but then going and finding the actual PR and going, hey, what's changed? And the reason it caught my attention to do that is sort of like what Mike was saying. There's, from what sounded like again, probably relatively simple when I saw it in the headlines last week. I'm like, okay, or mail list, whatever. I saw like some sort of WLAN thing going on. Great. But then when you actually look at the patch includes fixing Freescale Ethernet from Marvel, so all the different Ethernet chipsets, Broadcom. There's an ISDN change, some change in MediaTek Ethernet, some Hyper-V changes on their network stack, VLAN stuff, Mac VLAN. Finally, a wireless file changes, some more IEEE 2154 socket. I think that's for cars. But anyways, it becomes a bigger and bigger patch as you were explaining of like, they're like, oh, and this and this and this. So that's sort of interesting to make you go, what, that, as I said, it caught my interest to actually go and find the source and actually what's going on here. And it's probably an interesting read for 5-10 minutes to sort of poke around and get a sense of what do these look like when they're fixing, but also how did they get to, letter D from letter A? How did those 2 points sort of get made connected? So something simple can be a little more interesting when you look closer.
It can be. And I threw in another article to help us with looking at things more closely that actually dates back to, I think, 2019. It was Learning Linux Kernel Exploitation. So it's actually the part one of a 3-part series about kernel exploitation. And I really just threw that in there as a gift to our listeners. For those of you who love to dive into the internals of C structs and memory exploitation and heap exploitation in the kernel. But it did make me think of just wanting to make sure that we also bring in articles that are about general education, good references that don't necessarily age out over time. So I definitely, I'm going to hint to another article. Linux kernel hacking is not my strong sense of within the security community, but it's out there as a reference, and we'll try to include many more of those as we come across them, as well as listeners. If you got one, please share. And John, rather than quiz you on the internals of Linux kernel heap exploitation, I'd like to explain multi-factor authentication to me. I know we have things like 1FA, 2FA, and multi, I guess, can go over 2 into 3FA. Now, without laughing and trying to keep a straight face, you have to explain what 3FA is to us, please, if you can.
Yeah. Okay, so yeah, I had to go back and look at this one to make sure that he wasn't a employee of one of the vendors, and he's not. Um, and while we're going to make fun of this, I think the core idea, I get it, and I agree. So we'll start with what is 3FA, and in this article, there's two mentions of possible choices. One's coming from Microsoft, one's coming from Okta, and the idea is, okay, well, usually 1FA is something you know. 2FA is something you have. So first factor would be like a password or like, we'll say password, stick there. Second factor is something you have. So like a token or some sort of way of like putting a number in, right? We're sort of used to that. And the third factor, at least from the way we're talking about in this article, is locking that authentication so far. So basically to the computer you're attempting to authenticate from, or I should say the device. And the idea here being, if you've got that third factor, if you authenticate against your phone, even if someone's trying to phish you and trying to do a attacker in the middle type scenario, that the authorization is actually tied to something on the specific device. So if they take that same credentials and try to use them somewhere else, it ain't going to work. So Microsoft has that in, it's not M365, it's in their, I'm going to miss it, conditional access. And then Okta has in some of their stuff. But so those sound decent in general, but I think sort of there's a bit of a chuckle from us on the security side of like, okay, a third factor, how long till we get to the fourth? I think if we put on the zero trust hat for a second, I'm sort of curious about these from that point of view, and I just lost half the listeners. But from at least the ASW listeners, they really don't like that. But the other way to think about this here is, and I think I put into show notes, is this is sort of a game of whack-a-mole, right? So, 2FA was, and that's sort of what the article talks about too. 2FA was fine when it was, 50 of us, with an RSA token at a bank and nothing else. But now that it's become so massively common, just adding an additional hoop to jump through, which is what you're doing, is that really going to slow down an attacker? And from my point of view is, if I was that motivated, couldn't I just get myself onto that user's box? And then when they authenticate, I've got an authenticated pipe to access from. So that's sort of the pros and cons of it. But I thought it was sort of a bit of a chuckle and also a bit of something for us to keep our eyes on from a application authentication point of view.
Indeed it is. And I think the only thing I can add there is that I just saw that article and just with the idea that, he's talking about a user identity and a device identity. How are we demonstrating trust from something hopefully, or that should be a cryptographic anchor, whether it's the trusted enclave within your smartphone or within the laptop or something like that, so that we say like a WebAuthn protocol, you have that cryptographic proof that yes, at least whoever's using this phone that's the person who's been identified, and then the source they're coming from, the device, has also had its some type of assertion on its identity, so that it minimizes, as you said, John, just replaying the identity. So if we're going to use metaphors throughout the month of October for Halloween movies, this would be like the end of The Thing with two gentlemen sitting at a fire and just saying, let's see what happens. So if you haven't seen, no spoilers, go watch the movie The Thing. But while I'm thinking about horror movies and horror shows, there's a new timing attack that could lead to supply chain attacks. So supply chain is horrible and terrible, and this is yet another, and this feels like a sequel of some sort. What do we have to worry about this time?
This time.
Ha ha ha.
Can we rename the show What Do We Have to Worry About This Week?
I think you're onto something.
Why haven't we thought of that before? So we'll see how big of a deal this actually gets turned into. It sounds potential. It sounds of potential interest to me on the Kinsella scale. But so what's happening here? The idea is with NPM, the library which we oft talk about on this show for storing JavaScript node packages. Someone has figured out that there is a timing attack you can do when you make a request for a package. There's going to be two instances where you get back a 404. If the package doesn't exist, obviously you're going to get a 404 not found error. The second way is if the package exists, but it's a private package and you're not authenticated. So in that case, and there's a bit of a, I would say a religious thing there. If you're writing an API probably be a good interview question. If you're writing an API, and how do you respond to someone making a unauthenticated or a failed authenticator request for an object? Do you say authentication fails, or do you say object doesn't exist? 403, 404. But anyways, in this case, node npm is doing 404, but someone has figured out those two. One of those things takes longer than the other because they got to go and do a query against database, see if it exists. All that crunchy ends up being a few milliseconds or nanoseconds, what have you. But it's enough of a gap that people are able to figure it out. And why this is interesting in this particular case is if you're able to see that a package exists, but you're able to find out if a package exists or not. And once you have that, now you've got the ability to possibly start working on doing a typo squatting attack. So that's where things could get interesting. I'm not sure if I can't imagine that npm is going to let you have a public version of a private package, but you can start doing typos on that and try and get people that way. So that's sort of the attack angle here coming from. Interesting. It's not a slam dunk, but it sounds like, frequently when we talk about timing attacks, they're so sort of, it's more of a theoretical thing, especially with the cloud and things like that. But this seems like it has a little bit more meat on it. So that's why I thought it was sort of interesting that we might actually see something like this in the future.
It's definitely fun to be able to see a timing attack that can be pulled off over the network, so that it has at least enough of a jitter or a delay that it's discernible from there. I want to pull that into the Microsoft article I have about the because you kind of touched on how worried should I be, or in the sense of, is this a big issue? Are there other avenues to attack? And this article I'm referring to is basically a bug bounty report that was pointing out that Office 365 message encryption is using ECB mode. And for those of you who aren't familiar with ECB mode, there are, in block ciphers, they can have different modes of operation. And the classic ECB is basically, you can see the structure of the underlying data. So there's a classic example of the Linux penguin that can be encrypted, but you can still see essentially the silhouette of the penguin in a ghostly, spooky manner. And this is what the report is pointing out. Now, the reason I thought to talk about it is that there is a class of bug bounty type reports where a company, in this case, Microsoft, comes back and says, doesn't meet the bar for security. There's no breach here either. And since there was no code change, there's no CVE, and therefore, carry on, move along. That's not necessarily very welcome when you're the bug bounty reporter. And obviously, they're not out after this to highlight for a bounty itself. So I don't think from the conversation here, there's a financial motivation. It's more of, this is bad. Don't use message encryption because it will be insecure at scales, or there's lots of ways to attack it. But I think for me, I just was curious how many people use message encryption anyway. And there's there's also a tangent to go on of just, especially with email-based encryption, I don't know that we have any real effective email-based message encryption. Just use Signal, use, Apple iMessages. There's so many other better end-to-end implementations anyway that this sort of, to my perspective, gets, it was interesting, good point, glad they found that, but move along. There are just many better ways to handle this.
Yeah, you summed up my thoughts on it. I think some of these guys are doing better security-wise now if you stay within the providers. In other words, M365 to M365 or Gmail to Gmail. But still, it's that. Speaking of interview questions, it's used to be one of my favorite things to do to new employees or new employers. Like if they're asking for me to submit, pay stubs, or not pay stubs, but your checking information over email. It's like, really? We're a security company. We don't do that, right? But yeah, hopefully we all know we've got better tools.
So I have another interview question for you, John, and it goes, what is confidential compute?
Coco. So Coco's my new, I think this might be what they're actually calling it, confidential containers. I'm going to take these two at once. We've got two pairs.
Yes.
So I'm going to start on the bright side with Red Hat is backing a CNCF project to do confidential computing in containers. It's sort of an interesting space. I haven't looked at this, but I've looked at this closely in the past. How do you need to somehow get the blessing to run at least the way I've seen it done, a signed process that's now containerized, but to be able to access your trusted computing module on the CPU. How do you do that in a containerized environment? It wasn't really part of anyone's architecture originally, so that's what they're working on. But as I mentioned, it looks like it's actually a official, or not an official, I'll say a commonly used nickname for them to call confidential computers COCO, which is also our old trash 80s. The color computer. So that was sort of fun. But so this is something interesting, something good we're starting with. Red Hat's backing this. This is a thing. There's I'm going to sort of walk into the next story by thinking through, like, there's reasons people want to use confidential compute. And it really comes down to some sort of a shared environment, right? Whether that's shared in your office, maybe you're in college and you bought like one server for you and your 4 suite mates, and you all want to do your own thing privately. Okay, cool. Or public cloud, right? Or private cloud or community cloud or any of those. There's times and places where people need to be able to do computation and combining compute and data in a way that your neighbors don't see. That's the premise that we're coming from here with this, right? And there's some folks who won't use public cloud because of that, if they don't see some way of doing secure compute. So they might, you can figure out how big the biggest instance is at, I always think Amazon, but pick your provider, like, okay, which one has the max CPUs? That's probably a bare metal machine by itself, and you can do that and not be sharing a system with someone else. But that's sort of a sketchy way of doing it. So that's why people want this stuff. So I'm going to move on along to the second article from Corey Quinn, the cloud economist, and guy who pokes everyone in the side occasionally. So he has an article, blog post called "Confidential Computing is for the Tinfoil Hat Brigade." So that's why I sort of walks into sort of saying why some people are trying to use this. So now why do people think you don't need this? And his article is, I put this in here really to sort of to balance out. Once I saw his first, once I saw the Red Hat one, I'm like, okay, now we've got something we can sort of compare and contrast with, from the point of view of really what he's saying at the end of the day is security from a hardware point of view at a large cloud provider is a numbers game. Is someone going to track down where your data is? Like, so think about hard drive encryption, or data encryption is the other one. Is someone actually going to go to a trouble of encryption in rest of data? Clarify myself. But is someone going to go get access to the right data center, figure out the right server, and pull the right hard drive that your data just happens to be on? That's a pretty small risk. Does it exist? Yes. And I think we've seen some other cases where there's not so much a bad actor, but there's an accidental actor that somehow gets involved in there one way or another. I think that's when this stuff comes in handy. But he's got a similar thought around COCO, which is, you're not going to have malicious admins, or it's pretty rare. My thought in the back of that was Edward Snowden. But it's good to think through these things, right? It's at the end of the day, his point is confidential compute is, leave the actual sticker price tag out of it. The cost to actually get it working. I mean, you think like using containers and Kubernetes and stuff like this is bad. Good luck when they start throwing that COCO stuff in there, because that ain't going to be easy, right? But so you have to have a really good reason to do this, or maybe you're just not doing it for the right reason. So I think that's, it's worth thinking about those two and thinking through, is this something which is a thing, or what's the story?
Yeah, I think you bring up that great aspect, which I hope is a common theme that we try to touch on in these shows, is the idea of threat modeling and where is your security barrier? What's a security boundary? And are you asserting that this particular protection solution example or other aspect actually addresses the problem that you stated up front? And I think this is where you're highlighting what some of Corey's objections are about the threat models around this, at least stated, don't necessarily feel like the threat models that make a lot of sense or that everyone really needs to worry about. For me, I would slightly temper and this might be an expansion of COCO, confidential computing, into the aspect of the privacy preserving operations within the queries or working on the data, so that you can have developers, others, services querying and operating on the data that just say, is this a group? Does this group know the horror movies that came out in 1982 versus this is Mike who has been watching The Thing every year for the last 40 years, et cetera. That's maybe a little facetious, but I hopefully didn't lose the subtle difference there between something like, is this person a member of a set, or can I enumerate all of the qualities of this person or this data item that might be more privacy unfriendly? So fumbling through that a bit, but that is a little bit of an aspect that I'd throw onto here that I think is actually doesn't squarely fall into the security side of this discussion, but more so on the privacy side. I'm going to take that pause to gather my breath and turn us onto a different topic now. I threw together a couple articles about education or careers, I think, as well. Something that we've been talking about recently. You've got an article about working with developers too, John, but we're going to pause that for just a second as I introduce a field guide to the various communities of security from Phil Venables. So Phil's articles are definitely familiar to our listeners and those readers who've been checking out our show notes. This one is a list of over a dozen basically different disciplines within Infosec. And I like, if you skip down to number 15, this also talks about related disciplines, which privacy, the confidential computing, I was just touching on some of those items there, and trust and safety. That's also an area that I like to bring in when we talk about threat models. The idea, how could your application be abused against its end users? Rather, how could the application be abused against itself or against the data? But I thought that an underlying message of this article is that no one, I think, at this day can really be a generalist. And we have to acknowledge, and we should acknowledge, that people come into the broad umbrella of InfoSec, let alone application security, through many different venues. And that was my takeaway message. And I thought this was a pretty good summary or pretty good list of disciplines. Yeah. John, how do you fall into one of these, or is there a special case that is the Kinsella category?
Into a few different ones coming and going, right? And I think what's interesting about this is not just it's such a wide amount of information, or such a wide sort of area of fields of interest, I'll say. I think they're, at least in some cases, significantly different personalities, right? Enterprise security, sure. Cloud security, sure, love it. Legal? No, I don't want to do that. Audit? No. Right? So it's like there's some of these things in this list I'll happily do, or that I have lots of experience in, I really enjoy doing. I'm looking for something a little bit further. Offensive state security groups, haven't done that yet. Could be interesting. But, and I think that's what's sort of fun about this field is people always say, like, how do I get started in security? It's like, well, this is actually a good list from that point of view. Hell, throw someone at this, maybe print out a copy in your office, put up on a dartboard, and like have the new guys just sort of grab and throw and see if they actually find something that makes sense. Maybe you don't want them to office, maybe before people get to office, maybe college. But yeah, I think I haven't thought about it well enough to think if I would consider it to be comprehensive. It's pretty close to it, I'm sure. It probably is. I mean, it's coming from him. But it's a good list. Good to think about and sort of go, what do I want to do when I grow up?
It's a good list for all the reasons you throw in there. And I wanted to also highlight number 9, a small business, because one of the traps that we try to avoid, especially when we're pulling in articles, is not saying, oh, well, this is how Google's security team solved a problem. This is how Meta's security team solved a problem. It's more of, yeah, sure. If you have small businesses understaffed, they may not have explicit application security folks, so they need to rely on training their developers on secure coding, or need to rely on the developers to be shift left because there's no one else to shift to. So that's, I think, I appreciated seeing that being called out as just a different way of dealing with that challenge. And I think you're about to say one more thing.
Real quick on that one. What's missing from this list, actually, I don't think I see application security on here. It must be on in some way, shape. He's probably putting it underneath.
Hackers, researchers, perhaps, yeah.
But what's also missing under number 15 is software developers. We'll be in touch with Mr. Venables.
I'll let you send that email, John. But it is a good point because we can't forget about the developers. We've been talking about how do we teach developers either from the industry. We talked with Akira a little bit ago, and we talked about from the university perspective as well. Who's teaching secure development? And I have an article here from Portswigger, who was more of an interview format, talking with David Wheeler, who might be familiar to those of you who have been within the AppSec, Infosec space for quite a while. He's a well-known name. And he talks about where is the education for security? And he does lament that there was a course that I think George Mason has where he's teaching, but it was optional. So it's one of those aspects that it's not required as a fundamental that every comp sci student should go through. But this article does also link to the OpenSSF and some resources that they have. So there is a secure development course that they link to, which I think is free if you're part of the OpenSSF or can at least be obtained for a low price. So if you're an enterprise company, go support the OpenSSF so that you can get this type of information to your developers, because this is the type of thing we want to encourage and improve.
Definitely. And for those who haven't heard us talk about this enough, we had Janet Costello-Worthington on from Forrester, which this interview actually quotes, I think, her previous research. So go back and tie those two together and think a little more about the education side.
And there was, on the education side, I thought this was kind of a funny/fun article from a hacking class that got hacked, because there is an aspect of how do you set up an environment that has known vulnerabilities, purposely vulnerable systems, so that people can experiment, that they can play. And this article talks about doing so for a group of Stanford students, setting up in GCP, and they were vulnerable to Eternal Blue. But there was a small misconfiguration mistake that one of the instances was accessible from the internet. It got popped, and it was it was a neat article that's talking about the difficulty of setting up an environment itself, but then of course turning this into a lesson. How do we do? What went wrong here? How do we turn this into a very quick type of forensics insight? So, not sure there's more that I can pull out of this article, but I thought that was kind of fun. And anything else you want there to touch on there, John? Or yeah,
I think my 2 cents on that one. Then we'll hop over to someone else. Is It feels wrong to say it, so I don't want to take it in the wrong way. But it seems my sense is that everyone should have one of their systems compromised at some point in time. To take something like this class, go through it up on GCP or I can't say I don't want to say that because I want to say go get your systems hacked on Google, but right. Go out somewhere maybe I don't know. You're all creative people. You're smart. You're listening to this show. Go put something out somewhere on a Raspberry Pi on a Wi-Fi at Starbucks. How about that? There you go. Someone's going to hate me no matter where I go with this thing. But in other words, the experience of having something out there and watching it get that you'd known vulnerable, easily vulnerable, not like you left a SQL injection on your own bits of code, and letting someone actually get in there and seeing what happens and how quick it can sometimes happen, and in other cases it might take weeks or months or years. Anyways, that's I think it's worth doing, right? It's worth people, and you don't even have to, this goes for management as well as the nerds. It doesn't have to, and I put myself on both sides of that fence, but it doesn't have to be something super complex. And I think you can sort of get to the point where you can write a blog like this yourself. And I think not from the point of view of writing a blog like this yourself, but going, oh, it was that easy or it's that harder. I wasn't expecting this. It's one of those things when you actually see it, it becomes a little more tangent, a little more, you feel it, you touch it, you're touching the magic. San Franciscans will get that joke. So let's see. I want to go talk about cars for a few minutes if we have the mic.
Oh, please.
And we had something here previously about right at the top of our segment. But so, Hyundai and Kia. We've talked a few months ago about, let's see, I think we talked about Honda and the Civics were having issues with replay attacks. And I can't remember if we covered on this show. I know some of the Security Weekly shows covered Honda and Kia were having on some of their models. So it's standard nowadays if you've got a car key that you plug into your ignition, that there is a little chip in the key. So when that goes into your ignition and you turn it, if that chip's not there or the chip doesn't validate, car no start. It's called an immobilizer. It's like the idea is like to prevent someone with a screwdriver from coming along and just like, crank or hot wiring or whatever else. So it turns out on some models, Hyundai stopped doing that as a cost engineering thing. And some punks over on the TikToks went and figured this out and started showing people how to steal Kias. Okay, but so that happened. So the short of it here is Hyundai finally has a fix out, which they said would cost $170. And where I'm going with this, I'm talking about security tax, which we talk about like SSO tax, but here we're seeing it now with actual cars. So Hyundai has this thing which list price on the engine immobilizer is $170. It turns out when you call around to the various dealers, you're lucky if you get this for less than $30 more, $40 more actually. So there's an upcharge there. It looks like people are finding the same kit online for $60. So what is 60, they want to sell for 170, and dealers are selling for 210. And then on top of that, there's labor to install it at I don't know what it is nowadays in your average car dealer, probably $200 an hour, right? For labor, I think they're quoting 210. So, and the point being here, by the time you walk out the time you walk out the door from the dealership with your car in its new secure configuration, you're looking at probably over $700 US for what you could say was a mistake in the first place that Hyundai should have fixed. So it was just interesting to see that a different point of view. And Mike, I don't know if you have any deep thoughts on that. If you're a big fan of Kias, in that case, we will keep going. I got the head shake from Mike. Ford Mustang. The next Ford Mustang, we've got an article from Ars Technica, is super high tech. And we're seeing, I mean, we've got the Tesla. We've got all sorts of cars now that like you lose track of how many CPUs are in these things, plus how many networks. And there's an article anyways from talking about the new Mustang and the 2024 Mustang in particular. So Mustangs, been around for what, 40, 50 years. They're known for being like a hot rod car. You want to be able to replace your headers or your exhaust or the whole thing basically, right? A lot of cars like this. But that has a following. So now people are Ford's saying, as we add more tech in there, just from our own legality and human safety, we have to put security around this. We can't just put it out there so you guys can do whatever you want with it and reprogram a computer for, say, your fuel mapping. So they're trying to figure out what the point of this article is how do they balance? They still want to allow the people who want to mod their cars and get ready for Fast and Furious 25. How do you do that, but at the same time protect against the people who want to do bad things to your car? So that's sort of the trade-off that they're going to have to figure out the next year or two. Right now, they've locked it down, but it sounds like they're at least thinking about they might bless someone's tuning kits or something like that. So it'll be interesting to see how that goes, but just trying to provide things outside of our daily containers and clouds.
That's great. And what we should do is also throw in a link to the presentation on John Deere from this year's Black Hat or DEF CON, because that also touches on the right to repair. And people, I don't think anyone's out there drifting tractors, but Fast and Furious, you said it's what's up 25, maybe by the time they get into the 30s, they'll start stealing tractors, and that will be the case. But John, there's one final article. You said you're a manager, and I think you have an article about how you manage your developers. Is this what it is? So maybe we should close out on this.
Damn it, my secret's out. So over the fine folks at Hackaday, someone posted an article over there. And the headline was really grabby, but it is actually fairly, it's actually not sort of clickbait. So the headline of Hacking Developers with a Cat Feeder. Who's a good kitty? We haven't seen any cats yet on this episode, I don't think, for those watching at home. But what the developer figured out is, let's get a cat feeder. Let's fill it with human treats. I think he was using, I can't remember what he was using, but he had some sort of thing like, that we'd like chocolates or something like that. And what they did is, I think this one might have been connected to the internet in the first place. I read this last week and I've already forgotten. I'm sorry, people. I can't remember if the thing was internet connected or not. Anyways, he made the thing internet connected, probably threw an 8266 in there. And he then went into the office and hooked it up to their CI/CD system. So when there was a new commit or a new basically had a REST API. So once you have that, when something good happens in the office, treats would come out and the developers would be able to go and get their treats. And I thought that was sort of cute. So I'm not doing that with my teams yet, but I am taking it under heavy consideration. Yeah, got to motivate people one way or another.
We do. We got to motivate them one way or the other. Maybe that will be, we're still looking for candidates for more slogans for your t-shirt collection there, John. Maybe that one will go onto there. Let us know, listeners, what would go into the bowl to motivate you, or what should be another slogan that John should throw into his t-shirt queue. I want to say thank you, John, for joining us once again to walk through the range of news that we had this week. Thank you, of course, listeners, for putting up with us once again and joining us. Please do subscribe, hit that like button, check out the show notes. We'll send you a treat. And speaking of The Thing, go watch The Thing. It's a great horror movie to check out. And in the meantime, we'll see you next week on Application Security Weekly.